look up into the night sky to the great hunter Orion. In his shoulder, a star glows with a fierce red light. This is Betelgeuse, a supergiant so vast that if it took the place of our Sun, its surface would stretch beyond the orbit of Jupiter. It's a star at the very end of its magnificent life, and one day it will explode in a blaze of glory. But tonight, we're not just going to watch it from afar. Tonight, we fall in. As we get closer, Betelgeuse fills our view, its surface a turbulent, boiling sea. This isn't a star like our Sun. It's far older, much heavier, and dangerously unstable. While it's only about 10 to 20 times the mass of our Sun, it has swelled to hundreds of times its radius. Its wispy outer atmosphere is so enormous, it would swallow Mercury, Venus, Earth, and Mars without a second thought. Yet, for all its intimidating size, its surface is relatively cool. Cool for a star, anyway. At around 3,500 degrees Celsius. It's this lower temperature that gives Betelgeuse its signature red color, the beautiful, fading glow of its youth. We approach what looks like a surface, but a star has no solid ground to stand on. What we see are vast churning bubbles of plasma, rising and falling in a slow cosmic dance. These are convection cells, and they are mind-bogglingly huge. A single one of these bubbles can be larger than the entire orbit of Earth around the Sun. Hot, bright material rises from the depths, cools at the surface, and then sinks back down into the star. The entire star is boiling, slowly and magnificently. Now the fall begins. We cross the visible boundary, plunging into the glowing gas. The radiation around us intensifies instantly. The matter grows denser. Here, the intense heat strips atoms of their electrons, creating a superheated soup of charged particles called plasma. There is no air, no familiar fire as we know it. There is only raw energy and immense crushing pressure. We are inside a star. Unlike our Sun, which is steadily fusing hydrogen in its core, Betelgeuse's life is far more complex. That simple hydrogen burning stage is long over. Now, fusion happens in a series of layers, like a cosmic onion. On the outside, a shell of hydrogen is still burning. Deeper in, there's a shell of helium created from that hydrogen. Deeper still, a layer of carbon, then neon oxygen and silicon. Each shell burns hotter and faster than the one above it. The journey to the center is a descent into ever more violent and frantic nuclear reactions. These final stages of a star's life are incredibly brief on a cosmic scale. While the hydrogen burning phase lasts for millions of years, the silicon burning at the very heart of the star might last only for a few days. As silicon fuses, it creates iron. And for a star like Betelgeuse, iron is the beginning of the end. It's a dead end. Fusing all the elements up to this point has released energy which pushes outward and holds the star up against its own gravity. But fusing iron doesn't release energy, consumes it. When enough iron builds up in the core, the furnace suddenly goes out. The outward pressure that supported the star for millions of years vanishes in an instant. The result is catastrophic. Gravity wins. The core collapses in on itself in less than a single second. Protons and electrons are crushed together to form a ball of pure neutrons. This collapse then rebounds in a titanic explosion. A shockwave of unimaginable power erupts from the core, tearing the star apart. Betelgeuse becomes a supernova. For a few weeks, it might outshine its entire galaxy, a brilliant beacon visible across the universe. What would happen to us, to our imaginary probe falling through its layers? We would be obliterated, annihilated in a fraction of a microsecond. The matter around us would be torn apart, its atoms recycled in the heart of the explosion. No spacecraft, no conceivable technology could survive this event. But from our safe vantage point on Earth, hundreds of light years away, the show would be spectacular. A brilliant new light would appear in our sky, so bright it would be visible even during the daytime. A temporary, beautiful star heralding the death of a giant. After the cosmic fireworks fade, what remains? The core. That tiny, crushed remnant of the star's heart. It survives the blast, compressed into one of the most extreme objects in the universe. A neutron star, an object perhaps the size of a city, but containing more mass than our entire sun. A single teaspoon of its material would weigh more than all the mountains on Earth. It is the ghost of a star, a monument to gravity's ultimate power. But there is a surprising, beautiful truth to this violent death. A supernova does not only destroy, it creates. In that final, explosive moment, the intense energy forges elements heavier than iron, gold, platinum, uranium. The precious and heavy materials of the cosmos are born in these stellar death throes. The calcium in our bones, the iron in our blood, these atoms were all created in the heart of an exploding star and scattered across space. This cosmic dust and gas, enriched with new elements, will eventually gather to form new stars and new planets. And on at least one of those planets, life, our journey into Betelgeuse, is a journey into death. But it is also a journey into our own origins. Long before our sun or Earth ever existed, another massive star somewhere in our galaxy lived its life and died in a similar explosion. From the ashes and embers of that ancient supernova, our solar system was born. The planets formed and eventually life emerged. We are not separate from the stars. We are what they leave behind. We are, all of us, made of stardust. Thank you for joining this journey. If you find the universe as fascinating as I do, consider subscribing for more adventures into the cosmos. See you next time.